Top 1 Thorium Reactor. In the 1950s and 1960s, researchers in the United States explored thorium reactors as a safer alternative to traditional uranium nuclear energy. Early experiments suggested that thorium could produce abundant energy with less long-lived radioactive waste. Engineers believed this overlooked fuel could reshape the future of nuclear energy, offering a more sustainable and potentially global solution for growing energy demands. Thorium itself is not directly fissile, meaning it cannot sustain a chain reaction on its own. Instead, inside a reactor, it absorbs neutrons and transmutes into uranium-233, a fissile material capable of producing energy through nuclear fission. Experimental molten salt reactors dissolved thorium fuel in liquid fluoride salts, which operated at atmospheric pressure and high temperatures. This design reduced the risk of explosive pressure buildup and allowed for the continuous removal of waste. Engineers monitored neutron flux, heat exchange systems, and salt chemistry to maintain stable reactions. The molten salt also acted as both the fuel carrier and the coolant, simplifying the reactor structure compared to solid fuel rods used in conventional reactors, while allowing for rapid adjustments to reactor conditions for maximum efficiency and safety. Thorium promised advantages: greater fuel abundance, reduced risk of meltdown, lower quantities of long-lived nuclear waste, and an inherently safer reactor design. Some designs also made it difficult to divert materials for weapons use, highlighting its potential for peaceful energy applications. Despite promising tests, funding was redirected toward uranium reactors that supported weapons development and existing infrastructure. Thorium research declined and was largely shelved. Today, interest has returned in several countries with pilot projects and experimental reactors exploring its potential. But large-scale commercial thorium power remains unrealized, leaving it as one of the most debated and intriguing alternatives in nuclear energy, still capturing the imagination of engineers and scientists worldwide. Top 2. Liquid breathing. In the 1960s, scientist Leland Clark experimented with liquid breathing, a technique that uses oxygen-rich perfluorocarbons to allow humans and animals to breathe liquid instead of air. Early demonstrations with animals revealed that the lungs could absorb oxygen directly from the liquid, suggesting the potential for underwater exploration, medical applications, and prolonged survival in extreme environments. The idea sparked both excitement and ethical debate as it challenged the fundamental limits of human physiology. The technique works by filling the lungs with a specially designed liquid, which dissolves large amounts of oxygen and carbon dioxide. When the lungs inhale this fluid, the oxygen diffuses into the bloodstream, while the carbon dioxide is expelled back into the liquid, which is then replaced or recirculated. Perfluorocarbon liquids are chemically inert and non-toxic, allowing for long periods of immersion without causing damage to the tissues. Researchers have experimented with cooling the liquid to induce therapeutic hypothermia, protecting organs during surgeries, and even allowing for deep-sea diving without traditional gas mixtures. Precise control of the fluid's composition, pressure, and respiratory cycles is fundamental to preventing lung injury and ensuring adequate gas exchange. Liquid breathing offers remarkable possibilities for medical procedures, deep water exploration, and survival in environments where air is unavailable or hazardous. It demonstrates how innovative thinking can overcome natural physiological limitations. Although human testing remains limited and risky, research continues to influence medicine, diving, and emergency response technologies. The concept remains both a bold scientific experiment and a glimpse into the future of expanding human capabilities in extreme conditions. Top 3. Concorde. In 1969, Britain and France unveiled the Concorde, the world's first supersonic passenger jet, capable of crossing the Atlantic in less than 4 hours. When it entered commercial service in 1976, travelers could fly from London to New York at twice the speed of sound. The sleek delta-wing aircraft became a symbol of luxury, speed, and technological ambition. The Concorde achieved supersonic travel using 4 Rolls-Royce Olympus turbojet engines, equipped with afterburners for takeoff and acceleration beyond Mach 1. Its slender fuselage and highly swept delta wings reduced drag at high speeds, while a droop nose improved pilot visibility during landing. As the aircraft flew at a cruise speed of Mach 2, Air friction heated the outer skin to over 120 degrees Celsius, causing the fuselage to expand several inches in mid-flight. Specialized aluminum alloys handled the thermal stress, and complex air intake systems carefully slowed incoming air before it reached the engines. Engineers constantly monitored fuel transfer systems that shifted weight during flight to maintain balance and stability at supersonic speeds. The Concorde represented a breakthrough in commercial aviation, proving that routine passenger travel at supersonic speed was possible. It became an icon of prestige, serving celebrities, executives, and world leaders, while demonstrating advanced aerospace engineering. However, high operating costs, limited seating capacity, sonic boom restrictions, and environmental concerns restricted routes and profitability. After a fatal accident in 2000 and the decline in demand, the Concorde was retired in 2003. It remains one of aviation's most ambitious achievements, a bold leap that proved speed was possible, but sustainability was an entirely different challenge. Top 4. Vanna Black. In 2014, Surrey Nanosystems revealed Vanta Black, the darkest material ever created, capable of absorbing 99.965% of visible light. When applied to surfaces, it creates the appearance of a void with edges and contours disappearing from sight. The demonstration stunned artists, engineers, and scientists as everyday objects seemed to vanish into absolute darkness. Vanta Black is composed of vertically aligned carbon nanotubes, microscopic tubes of pure carbon grown on a substrate. When light hits the surface, photons become trapped between the tubes, reflecting repeatedly until they are converted into heat and absorbed. The material's structure prevents reflection, giving it the visual effect of infinite depth. Applied coatings require precise deposition under controlled temperatures and vacuum conditions. The nanotube layer is extremely delicate, often protected by additional layers for practical use. Engineers utilized it to reduce stray light in telescopes, improve infrared sensors, and even explore military camouflage applications. The material revolutionized optics and artistic expression, offering unprecedented control over light and perception. Designers and researchers saw possibilities ranging from more precise scientific instruments to new forms of visual art and immersive screens. Although Vanna Black captures the imagination, its application is limited by cost, fragility, and complexity of handling. Currently, only specialized environments and instruments use it, leaving the rest of the world to marvel at its near-magical darkness. The effect continues to inspire innovations in science, technology, and the creative arts, blurring the line between material and visual illusion. Top 5. Iron Lung. In 1928, American engineer Philip Drinker developed the iron lung, a negative pressure ventilator designed to help patients suffering from chest muscle paralysis induced by polio. At the time, polio outbreaks caused widespread respiratory failure, leaving many unable to breathe without help. Hospitals faced a crisis as conventional ventilatory support was insufficient for severe cases, which drove the urgent development of mechanical solutions. The iron lung is a large cylindrical chamber in which the patient lies with only their head exposed. A motorized pump cyclically changes the air pressure inside the chamber, creating negative pressure around the chest cavity. When the pressure drops, the chest expands, pulling air into the lungs. When the pressure rises, the chest contracts, forcing exhalation. This mechanical replication of normal breathing allows patients with paralyzed respiratory muscles to survive for long periods, sometimes weeks or months, until natural function returns or permanent care is provided. The initial use of the device drastically reduced mortality among polio patients in hospitals worldwide. Entire wards were equipped with iron lungs, and medical staff developed protocols for long-term care, monitoring, and hygiene inside the confined chambers. Despite its effectiveness, the device was large, clunky, and required continuous electricity and supervision. Later innovations, such as positive pressure ventilators and portable respirators, gradually replaced the iron lung. Although some patients continued to rely on it for decades, the invention marked a milestone in life support technology, demonstrating that mechanical ventilation could sustain patients with otherwise fatal respiratory failure. It also laid the foundations for modern intensive care units and ventilator design. The iron lung remains an iconic example of engineering, responding to urgent medical crises and showing how innovation can save thousands of lives in extreme circumstances. Its legacy persists in respiratory therapy and intensive care. Top 6 Project Pluto. Between 1957 and 1964, the United States Air Force developed Project Pluto, an experimental nuclear-powered cruise missile designed to fly at low altitude for thousands of kilometers. The concept envisioned a weapon that could remain in the air for days, delivering nuclear warheads while emitting lethal radiation along its path. The first tests of its reactor system impressed engineers with its raw power and terrifying potential. At the heart of Project Pluto was a nuclear ramjet engine called Tori. Unlike conventional missiles that carried chemical fuel, this system used a compact nuclear reactor to heat incoming air directly as the missile traveled at supersonic speed. Air entered through the front intake, passed through the reactor core, where it was heated to extreme temperatures, and then expanded through the rear to produce thrust. The reactor contained thousands of ceramic fuel elements designed to withstand intense heat and radiation while maintaining airflow. Since it did not require traditional fuel, the missile theoretically had unlimited range, restricted only by structural limits in the reactor's durability. Engineers tested the reactor on huge platforms mounted on rails in Nevada, measuring thrust, temperature stability, and radiation emission. Project Pluto promised an almost unstoppable strategic weapon, capable of evading defenses by flying low and fast. Its endurance and destructive capacity reflected the extreme military thinking of the Cold War era. However, the missile's radioactive exhaust, the uncontrollable risk of fallout, and advancements in intercontinental ballistic missiles made the concept dangerous and strategically obsolete. The program was canceled in 1964. Project Pluto remains one of the most controversial weapons concepts ever designed, a chilling example of nuclear technology taken to its absolute limits. Top 7. TR-3B Astra. Since the 1980s, conspiracy theories and alleged sightings have described the TR-3B Astra, an anti-gravity triangular aircraft supposedly developed by the United States military. Witnesses report glowing and silent triangular ships, hovering or moving at incredible speeds, sparking fascination and debate about secret aerospace technology. Photographs, radar signals, and anecdotal accounts have fueled speculation, mixing fringe theories with glimpses of advanced military research. Reports suggest that the TR-3B employs a rotating plasma core, producing a strong magnetic field to neutralize gravity and stabilize the craft. Observers claim it uses exotic propulsion, allowing for abrupt accelerations, silent hovering, and nearly instantaneous changes in direction. The triangular design supposedly maximizes lift and stability, while onboard systems supposedly protect the vehicle from radar detection. Engineers, if the craft exists, would need to manage massive electromagnetic forces and energy consumption, balancing stealth, propulsion, and safety in ways far beyond conventional aircraft. Interest in the craft highlights the allure of unexplained technology and the human fascination with breaking the limits of flight. It has inspired aerospace enthusiasts, UFO researchers, and speculative engineering studies. Whether fully operational or purely anecdotal, the TR-3B remains one of modern aviation's most enigmatic stories. Its legacy is less about confirmed technology and more about imagination, secrecy, and the possibility of hidden breakthroughs just beyond public knowledge. Top 8. Cymatics. In 1787, physicist Ernst Chladni revealed cymatics, the phenomenon where sound creates visible patterns on surfaces. By spreading sand on vibrating metal plates, he revealed intricate geometric shapes that formed and changed with different frequencies. The demonstrations captivated the public, showing that sound could produce tangible and almost magical effects on matter, bridging the gap between science and art. Chladni's experiments involved applying a violin bow to metal plates covered with fine sand or powder. As the plate vibrated at specific frequencies, standing waves emerged, causing the particles to settle along nodal lines, where vibration was minimal. Each frequency produced a unique pattern, from simple circles to complex star shapes, illustrating the direct relationship between sound waves and physical structure. Modern studies have expanded the method using liquids, gels, and digital visualization, exploring how vibrations influence matter at micro and macro scales. Cymatics is now studied not only for artistic purposes, but also for material manipulation, acoustic research, and even therapeutic applications, showing its surprisingly broad impact. Cymatics demonstrates the profound interplay between sound and form, revealing that energy can manifest visually and tangibly. It has inspired both scientists and artists, joining experimentation with aesthetic exploration. Although initially a curiosity, Chladni's work laid the foundations for modern acoustic research and artistic applications. The phenomenon continues to fascinate, showing that even invisible forces like sound can leave visible traces in the world, influencing both science and creative expression today. Top 9. Nimrud Lens. In 750 BC, Assyrian artisans ground a piece of natural rock crystal into a precise oval lens, with optical properties that should not have existed for another 2,000 years. Scientists still cannot agree on what it was used for. The lens was discovered buried in the throne room of the Northwest Palace of Nimrud, in present-day Iraq. It measures 38 millimeters in diameter and was carefully ground and polished into a convex shape, requiring sophisticated knowledge of optics and considerable technical skill to achieve without modern tools. When held to the eye, it magnified objects 3 times their actual size, with a focal length of 12 centimeters. When directed at the sun at that same focal length, it concentrated sunlight onto a point hot enough to ignite the material below. Both functions were tested and confirmed on the original object. The debate is not whether it functioned as a lens, but for which of these two functions it was primarily built. 3 theories have been proposed: a magnifying glass for Assyrian artisans, who regularly produced engravings so small that they should be impossible to create with the naked eye; a burning lens to concentrate sunlight into ceremonial fires; or part of an ancient telescope, a controversial theory supported by the fact that Assyrian astronomers demonstrated knowledge of astronomical details that should be impossible to observe without optical magnification. The British Museum stated that its optical properties were most likely accidental. However, the lens fits comfortably in the hand, has consistent curvature, and produces measurable magnification. Accidents of this quality do not happen without intention. It is located in the British Museum today, being the oldest known lens in human history, still without a consensual explanation after more of a century of study. Top 10. Amber Room. Built between 1701 and 1709, this chamber of gold, amber panels, and mirrors was originally commissioned in Prussia and later gifted to Russia. Visitors to the Catherine Palace in St. Petersburg marveled at the warm glow, the intricate craftsmanship, and the shimmering amber mosaics, earning it the nickname of the 8th wonder of the world. Its combination of art and opulence made it one of Europe's most celebrated cultural treasures. The chamber was built by joining carved amber panels with a gold leaf background, mirrors, and detailed woodwork. Artisans carefully arranged amber pieces in subtle gradient tones, while carefully positioned lighting enhanced the natural translucency, giving the space a radiant and almost ethereal glow. Specialized adhesives and assembly techniques maintain structural stability without compromising the delicate design, showing the combined skills of woodworkers, jewelers, and architects at the height of Baroque craftsmanship. In addition to its aesthetic appeal, the room symbolized political power and artistic achievement, representing wealth, sophistication, and diplomacy. It inspired admiration and envy across Europe and became a defining example of Baroque luxury and ingenuity. During World War II, the chamber was dismantled and looted by German forces, and its fate became one of the greatest mysteries in art history. Today, a meticulous reconstruction is in its place, while the original remains lost, leaving behind a story of intrigue, speculation, and the enduring legend of a missing masterpiece. Top 11. Number stations. During the Cold War era, mysterious number stations broadcasted encrypted sequences of numbers via shortwave radio, capturing the attention of listeners worldwide. It was believed that these seemingly random voices, often reading sequences of digits or letters, transmitted secret messages to spies behind enemy lines. Both ham radio enthusiasts and intelligence agencies monitored the signals, fascinated by their eerie consistency and undetectable origin. The stations operated using high-frequency radio transmitters, sending pre-recorded or live voice sequences at scheduled times. Each set of numbers corresponded to encrypted instructions, decoded only with one-time pads held by the intended recipient. The transmissions were deliberately repetitive and monotonous to reduce errors, and transmitters were often relocated or disguised to avoid tracking. Some stations used synthesized voices, while others employed human announcers, creating distinct signatures to indicate the type of message or sender. The technology required precise synchronization, encryption techniques, and secure transmission protocols to ensure that only the target agent could understand the communication. These transmissions offered a reliable and anonymous method of long-distance espionage without depending on telegraphs, telephones, or other interceptable channels. They became iconic symbols of Cold War secrecy, inspiring curiosity and speculation about global espionage networks. Despite the decline of traditional espionage methods, some stations continue to broadcast today, maintaining the mystique of encrypted communication. They remain a haunting reminder of an era when invisible signals carried the weight of international intrigue, and the world tuned into voices that were never meant to be fully understood. Top 12 Spruce Goose. In 1947, aviation pioneer Howard Hughes unveiled the Spruce Goose, officially named the Hughes H-4 Hercules, the largest flying boat ever built, designed during World War II to transport troops and cargo across the Atlantic. The massive wooden aircraft impressed spectators with its gigantic wingspan and almost mythical presence. In its only flight, it took off from the water for less than a minute, proving that it could fly, even if briefly, and consolidating its place in aviation history. The aircraft was built primarily with laminated birch wood due to the shortage of aluminum during the war, using a process called Duramold, which joined layers under heat and pressure to achieve strength. It relied on 8 Pratt & Whitney radial engines mounted along its wings, generating enough thrust to move the 180-ton aircraft. The wingspan measured nearly 98 meters, longer than most modern commercial aircraft, providing the necessary lift for heavy loads. Engineers designed a hull capable of operating as a boat with reinforced ribs and internal structures to distribute structural stress. The control systems, fuel management, and aerodynamic balance had to account for the immense size and weight of the aircraft, making it one of the most complex and ambitious aviation projects of its time. Hughes and his team faced unprecedented engineering challenges, including structural tests, weight distribution, and engine coordination, all under intense public and government scrutiny. The Spruce Goose symbolized American industrial ambition and wartime innovation, demonstrating that even seemingly impossible engineering challenges could be faced with a bold design. It expanded the limits of aircraft scale, materials, and aerodynamics, inspiring future generations of aerospace engineers and enthusiasts. Delays, budget overruns, and the end of the war eliminated its original purpose. Only one prototype was completed, and after its short flight in 1947, it never flew again. Today, it remains as a monument to ambition and ingenuity, an aircraft that proved it could rise but never had the chance to reach its full potential, continuing to capture the imagination of historians and aviation fans worldwide. If these stories of forgotten technology and lost wonders change the way you see the limits of human ingenuity, please subscribe and like the channel. We are unearthing the history that they tried to bury. Let's plant the seeds of the future together. The next treasure will be revealed soon.